أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم.
In this session, I'm going to talk about how to establish convergent validity using SmartPLS4 and what to do if you encounter certain issues. Let's go to SmartPLS4. Now, once you have built this model in SmartPLS4, how to do this, I'm going to share the video that has already been uploaded. So let's say we go to calculate. Let's do it again, PLS algorithm, path, standardized, default, just start your calculations. Now here is your output. Now these here are your loadings, and this is your R square, these are your loadings. Your AVE is calculated based on these loadings. Now for now I'm interested in finding out whether my AVE values are greater than 0.50 for these two constructs. If you hover your mouse around this latent construct, you will see the AVE values at the end, the average variance extracted. Here it is. This one here, 0.618. And for this OP, it is here, 0.742. Now in both cases, the value is greater than 0.50. This means that these items here are converging to represent this underlying construct. They are coming together to represent this underlying construct. And each of this item, because the value is greater than 0.70 for each one of them, is adequately representing the underlying construct. And same is the case for OP. These items are converging to represent the underlying construct. Now where is your value of AVE in the report? So if you go to report here, in the quality criteria, there is construct reliability and validity. So if you select overview here, and you will have your AVE value. And this is greater than 0.50. What if this would have been less than 0.50? What step one should have taken, or what steps we should have taken to improve this AVE value? And how many items shall we delete when there is low AVE value for a particular construct? Now the first step that you should have undertaken is go to the graphical output. Okay, where is your output? Go to reports again. Let's go to the last output. Let's go to the graphical output. Is there any value less than 0.70? If there is a value less than 0.70 and your overall AVE is less than 0.50, this means that particular item is the culprit and may be removed. Same is the case for the other construct. So you start with lower loadings because these loadings are used to calculate AVE. How? Let me show you. Now here is a sample calculator for average variance extracted, and here is the formula. So what you have to do is you have to square each of the loading for a particular construct and then sum those squared loadings and divide it by n, the number of items. Now in this case, have a look here. Let's do it for CC. So if you go to report, and where are your outer loadings? Here they are. Let's go to metrics, and you can copy these here, select them and right click, copy. Now once they are copied, let's take it there, let's put it here, press Ctrl V, and now these are your loadings. These are squared and six number of items, and the AVE is 0.6177. Is that so? Let's go to your output. 6177 when rounded off is 618, or rather 0.618. So this is correct. So this is how your AVE is calculated. So each of the loading is contributing towards the calculation of AVE. Now if a loading is less than 0.70, let's assume this one, the first one here, is not 0.759. It is, let's say, 656. Now this is less than 0.70. Shall I delete it? No, I will not delete it. Reason being that although it is less than 0.70, overall your AVE is greater than 0.50. Now let's assume, what if this would have been less than, let's say, 0.55. Still it is fine. Why it is fine? because the others are contributing. The others have loadings way over 0.70. So they are contributing to the low loading here. Now let's change this a bit further. Let's say we've got 0.45 here, 0.51 here. Now have a look here. Now these three loadings may be problematic. Shall I delete all these three? No. I will start with the deletion of this value here. Let me delete this. Now that I've deleted the value, let's say 0, the AVE is 0.478. Now what should I do? It is greater than 0.4 but less than 0.5. The recommended is 0.5. Shall I delete these two? Now in this case, I won't delete any further. Reason being that when your AVE value is greater than 0.4 and your CR value, that is your composite reliability value, is greater than 0.7, according to here, and the reference will be shared in the description, you can say your convergent validity is established. So I only deleted the item because it was helping me improve my AVE. Now let's assume, what if this would have been 0.35? Now this is very low. This is less than 0.40. So I will delete it. So you only delete items that have loading between 0.40 and 0.70, that is less than 0.70 and greater than 0.40, if they are significantly contributing in improving your AVE values over the required limit. Now I'll share a paper of mine as well, whereby I've used a similar approach. Now this is the paper in which I've used a similar approach, and I will share the link in the description as well so that you can read through the paper. And here it is, reliability and validity analysis, and here I've put in all the detail as to generally items with outer loadings 0.40 and 0.70 shall be considered for removal only if the deletion of the items results in an increase in composite reliability or average variance extracted over the recommended values. Here et al. 2016. And this is how I used it in my paper. Now that you have established convergent validity through average variance extracted, again let's focus on the issues. What are the issues in convergent validity? One of them is low AVE. And what happens? What shall we do? You should first check for item loadings, as we did. First, only delete items with loadings less than 0.40 if there are any. Next, if this does not solve the issue, remove items that are less than 0.50. If the AVE and CR values are found adequate after removal of items less than 0.40, then the items with loadings between 0.40 and 0.70 may not be removed. But if the problem persists, you can move on and delete items with loadings less than 0.70, but start off with 0.50, then move towards 0.60, and then move towards items with loadings less than 0.70. Items with loadings 0.40 and 0.70 shall only be removed if the removal of the items improves composite reliability and average variance extracted well above their required threshold. If constructs are already over their threshold value for composite reliability and average variance extracted, you do not need to remove the item. Now the next step in measurement model assessment is your discriminant validity. Discriminant validity in SmartPLS4. Discriminant validity is utilized to establish distinctiveness of the different constructs in the study. Is the extent to which a construct is empirically distinct from the other constructs in the study. It is the empirical establishment of distinctiveness, or how different is one construct from the other. Because in social sciences research, different concepts may overlap. So it is very important that you establish discriminant validity. Now in order to establish discriminant validity, we've got different methods. The first one, and probably the most used and the older method, is Farrell-Larker criterion. Now Farrell and Larker criterion that was proposed by Farrell and Larker in 1981. It is a traditional metric and suggested that each construct's square root of AVE that we already calculated earlier for convergent validity and is referred to as within construct variance. Now this should be compared to inter-construct correlation, that is the measure of shared variance, and your within variance or variance within the construct shall be higher than the shared variance. If that is the case, then Farrell and Larker criterion shows that discriminant validity is established. Now how do we do this? Let's have a look. Now again, the same example. Let's go to reports, the same old report, discriminant validity and Farrell and Larker criterion. Now this one here, this value 0.786 is the square root of AVE for CC. How do I know this? Let's go to construct validity 0.618, and if we take its square root, that will come down to 0.786. Now this is within construct variance, that is variance within collaborative culture. Now this should be higher than its correlation with all the other constructs in this study, that is shared variance. In this case, we only have one other construct, that is OP. Is this greater? Yes, this is greater. So no issues of discriminant validity here. The next one, 0.861. This is the square root of AVE for OP. Now is the correlation of OP less than the square root of AVE? Or in other words, is the shared variance less than variance within? Yes, it is. If you look here, this value is greater than this value here, which is the correlation between CC and OP. Otherwise, you can just copy this value here, paste it here in Excel sheet and make the comparisons. The reason there is no value here, because the value is repeating. The correlation between CC and OP is the same as correlation between OP and CC. Now let's say if I add one more construct just for the sake of understanding. Let's say I'm going to add OL. Let's drag it and drop it here. Yes, that's fine. Let's connect it here. Let's calculate or run PLS algorithm again, and reports, discriminant validity, Farrell and Larker criterion. Now look at this. This value here is higher than these two values. This value here is higher than this value, but this is only one comparison. What about OL and CC? There is no comparison between OL and CC. You can just simply copy the value between CC and OL here over here, because the correlation between CC and OL is the same as the correlation between OL and CC. Now this value here, this is the square root of AVE, shall be higher than the correlation of this construct with the other constructs. Now let's do it in Excel. Let's copy this, copy, and let me open Excel. Let's paste it here. Now this is square root of AVE, bold and italic. Is this value, that is variance within collaborative culture, greater than its shared variance with the other constructs? Yes, it is. Now is this value here, OL, that is variance within, greater than its correlation with the other constructs? Now we only have one correlation here. Where is the other correlation? The other correlation is here, OL to CC, OL to CC, or we can copy it here. So now this value is greater than these two values, so your discriminant validity according to Farrell and Larker criterion is established. Now what is this? Where should I compare this? There are no values underneath, so you can compare it to the values on the left, or either you can copy them here. Let's say OP to CC is the same as CC to OP, and OP OL is the same as OL OP, which is 0.631. So let's copy it here. And now look at this. This value is greater than these two values. This value is greater than these two values. And this value is greater than these two values. Hence, according to Farrell and Larker criterion, your discriminant validity is established. Moving on to the other methods. Heterotrait monotrait ratio. Heterotrait monotrait ratio, or HTMT, is a measure of discriminant validity. It is a modern measure. The HTMT is the mean of all correlations of indicators across constructs measuring different constructs. That is the heterotrait heteromethod correlation relative to the geometric mean of the average correlations of indicators measuring the same construct. So heterotrait means the correlation between different constructs, and monotrait means the correlation within the single construct. And then they are calculated using a formula to give us HTMT ratio. Now here is your HTMT ratio, and if you look here, all these values are green. The values are less than 0.85, so they are green. That is a more conservative measure, that is 0.85. That is a bit strict. You can have 0.90 as well, and that is recommended as well. In this case, they are well below 0.85. This means there are no issues of discriminant validity according to heterotrait-monotrait ratio. And you can say there is distinctiveness in the constructs. Now moving on, let's go to the final assessment, that is cross-loadings. An item in a construct shall load substantially well onto its own parent construct instead of the other constructs in the study. And if it is loading on the other constructs, then obviously it is not representing its underlying construct, and then there will be discriminant validity issues. Now how do we look for this? Let's go back to SmartPLS and have a look here. Now if you simply copy it, let's copy it, right click, copy, and put it in Excel. Here it is. Let's increase the size a bit. Now if you look here, this is CC1, 2, 3, 4, 5, 6, and this is CC. So these loadings here are for CC1 if that particular item is with its own parent construct. Now in this case, these items, when they are with its own parent construct, they should load substantially well in comparison to when they are with the other constructs in the study. Is the item, when it is with its own parent construct, loading substantially well in comparison to the other constructs? Yes. Is this the case for the rest of them? Yes, it is. And no value here is greater than 0.70? No. So there is no issue of discriminant validity here. Now let's look at OL1. So OL1 here, OL column here, OL1 when loading onto its own parent construct has a higher loading in comparison to other constructs. Same is the case for the other items in here. So no issue of discriminant validity. And finally, OP loading well onto its own parent construct instead of OL and CC. Yes, it is. So there are no issues of discriminant validity. Now this is how you can establish discriminant validity using SmartPLS4. What happens, or what shall be done if there are issues in discriminant validity? So here are a few steps that one might take if you are facing issues in discriminant validity. Now what should you do before collecting the data? Now there are always precautions that must be taken before the data is actually collected. The first one is make sure you have adequate number of items in each scale or construct. There should be at least 4 to 6 items since in SCM items are deleted if they fail to load or due to cross loadings. Now you should have adequate space for yourself if you've got low loadings or if items are cross loading. Normally it is preferred to have at least 4 to 6 items. Make sure item statements are easy to understand so the respondents can fill them adequately and appropriately. Make sure there is no overlap in the statements of different constructs. Now, if the statements from different constructs overlap, the responses are going to be similar. If the responses are going to be similar, there is going to be high correlation. That means cross-loading. That means violation of discriminant validity. Now, how do you solve discriminant validity issues once you have collected the data? The first thing, make sure to clean the data. Now once you clean the data, then you know that whether there have been a respondent's misconduct. Now what if you are cleaning the data, and as identified earlier in the videos on cleaning the data, the link will be shared in the description. What if there is no standard deviation in the responses? Then your discriminant validity will be high. Check the standard deviation in responses. Standard deviation value less than 0.25 mean that the probability of respondents misconduct and the responses for the questions are almost similar. Assess cross-loading. If an item is loading well onto another construct instead of its own construct, that particular item shall be removed. For example, an item has loading over 0.70 on two constructs. Now, for example, let's assume this example that we have already done. Let's go to the graphical output again. Let's assume we have discriminant validity issues. For now, this is an assumption. Let's assume I've got this variable here, these items belonging to OL. So the loadings must be high in here in comparison to these here. So OL2 here must load well onto its own factor here instead of here with CC or here with OP. Now let's assume there is an issue of discriminant validity between CC and OL. How would I know that if there is an issue of discriminant validity between CC and OL? If you go back and let's see Farrell and Larker criterion. Now CC and OL, this value here will be low and this value here will be higher. Otherwise, this value here between CC and OL, it will be over 0.85 or 0.90. Now you should be cautious. If it's over 0.90, then there are discriminant validity issues. If it's between 0.85 0.90, then to a certain extent you are fine, you are good to go, but still check for cross loadings. In this case, let's assume this is greater than 0.90, just an assumption. So what will I do? I will come to cross loadings, and when checking the cross loadings, let's assume this is 0.720. Now look at this value here and this value here. CC1 is also loading strongly onto OL. Now the difference is equal to this value here minus this value here is less than 0.10. This difference here should have been over 0.10. And this loading here is substantial onto the other factor. Now this item must be removed. Similarly, you can check for all the items. If you think that there is an issue of discriminant validity between any of the constructs, look for their cross loadings. Look for the item that is loading well onto other constructs instead of its own construct. This is how you can solve the discriminant validity issue. Moving on. Check for cross-loading. If an item cross-loading and the difference is less than 0.10, remove the item or items. Now check for low loadings. If the loadings are less than 0.540, then obviously there could be issues. Now if the problem persists, try collecting more data. Or if there is very high correlation, that is, the HTMT ratio is very high or the shared variance is very high, you do not have any other option but to combine those two constructs. Now this is primarily very appropriate for the constructs that have multiple dimensions and those dimensions are for the same construct. Now if the problem still persists, dropping one or more independent variable, that is collinear variables that demonstrate insufficient discriminant validity from the model, may help. Now this is the reference that can be referred to in order to know more about discriminant validity.